Hi, everyone. My name is Travis Rector, and I'm a professor of physics and astronomy at the University of Alaska Anchorage. And I'm also one of the co-founders of a group called Astronomers for Planet Earth, which is working to help astronomers and people in general address the climate crisis. This is the Q&A session with Dr. Olivier Berné, who is a research scientist in astrophysics at CNRS in Toulouse, France. If you are watching this recording and you have not yet seen Dr. Berné's original talk, there is a link to his talk in the description of this video. So I highly recommend you go ahead and watch that first. The purpose of today is to talk to Berné about the Q&A, talk about questions we have about his presentation. And so, Dr. Berné, thank you for joining us today.
Thank you very much.
Okay, so my first question for you is a rather simple one. It's been almost a year since we recorded your original webinar, and I have to apologize for taking so long to get it processed and ready to go. In your talk, you said that your project, Lavos 1.5, was about 2 years old at that time, so you're now in year 3. Do you have any updates you'd like to give on the project? Excuse me, the project and the results from it?
Yes, so basically we've been moving a lot in the last year, and we've been accumulating quite a lot of data. We now have about 400 research labs who are contributing to our database on the greenhouse gas emissions of research. So that's quite a large database. So we have consolidated figures on the origins of the emissions. So I can quickly show you those results, because it's similar to what I've shown in my presentation last year, but except we have more data and more significance. So this is what you can see here. I hope you can see properly.
I see it just fine.
So yeah, okay. So this plot shows the raw emissions per capita in tons of CO2 equivalent in 104 research laboratories. So those are the research laboratories who finished doing the measurement of their carbon footprint with the tool JES 1.5 that we developed within the project. So there is a reference a paper which is a preprint which describes this tool. I can provide the link for the commentaries. And so what you see here is the distribution of emissions. Each point here is a research lab for different sources of emissions. And what you can see here is a box plot. It's something that is used a lot in biology, for instance. It's not used that often in astrophysics. But basically, what these boxes show is the median value of emissions for each source of emission. Here, this bar here is the median value, and the edges here are I think it's the 95% percentile, and here you have the outliers. So basically what you see in this plot is that what we find from all this data is that travels are the primary source of emissions in these research labs. If you include the contrails, so that means that you include the indirect effects of flying, not related to CO2 emission, but also the effects of water vapor, etc., that are related to flying. This is the value we obtain. You see, is a bit lower for traveling without considering contrails. Then we have the heating of buildings, commutes, electricity, and then cooling and vehicles owned by the research labs is not something very important. basically, I mean, what is also very important in this plot is you see all these, there is a lot of spread in the data. And I think that's also very important to insist on the fact that there is a lot of heterogeneity, and that some research labs have a huge footprint related to traveling. Some other research labs have a huge footprint related to heating versus the rest of their sources of emission. And so that globally there is a large heterogeneity. However, we now have a global picture of what the sources of emissions are in these research labs. We still need to include other sources, such as the carbon footprint related to infrastructures. There was quite a lot of noise in the astronomical community lately about the fact that telescopes have a very important footprint, and purchases, which we have now included as well. When you buy something and you consider the life cycle analysis of what you're buying, this has a carbon footprint. And what comes out of our preliminary analysis is that purchases is probably as important as this source of emission. So it represents a large fraction of the total emissions in research. Something we've played with also is to compare the effect of COVID crisis on the emissions for different sources of emission. And what you can see here is that, of course, this is in green 2019, and in orange this is 2020. You can see, of course, that traveling was reduced significantly during the COVID pandemic, as well as commuting, whereas heating and electricity, for some reasons that we do not perfectly understand for the moment, are quite similar in 2019 versus 2020. So this is another an additional aspect that we got in the analysis. And another analysis we did is simply to try and see, for instance, if we can find typical correlations, expected correlations. That is, for instance, that the emissions of research labs is related to the headcount in the labs, or the budget in these research labs. So you see that there is quite obviously a strong correlation between CO2 emissions and the number of people in a research lab and the budget of a research lab. This is also this kind of correlation is something you also can see at a macroeconomic level. For instance, that CO2 emissions is related to the GDP of a country, for instance. So these are the main updates. I would say it's really the data that came out of our data collection on greenhouse gas emission of research.
Interesting. So I have a question for you related to this plot. Of course, astronomers don't have labs in the same way that many other branches of science do. So how do astronomers fit into these plots? Is this does this count, like, does the laboratory count as the observatories or the departments, or how do we fit into this?
Some of these dots here are actually astrophysics institutes. So when we say, and this is explained in the paper by Jérôme Mariette, when we say research lab, we mean this in a quite general in a quite general term. It means it's not necessarily people doing lab work in a physical laboratory with experiments. Rather, it's just a research institution where you have scientists working on a subject, and this includes, for instance, laboratories, or in fact, in French, it's laboratoire, where we're doing fully astrophysics, and also some institutes on humanities, for instance. It's not necessarily anything related to really lab work as we can imagine it in a strict sense.
Okay, that makes sense. So in your original talk, you described a very impressive number of institutes that had participated in the study to determine the carbon footprint. Do you have information about actions that have been taken by these laboratories or institutes to reduce their carbon emissions? Obviously, COVID has reduced our travel, but what are some of the other things that laboratories and institutes have been doing?
Indeed, some of them have started to really they're starting to change things by putting quotas, for instance, or putting some taxes on flying, for instance. This is something we have seen in some institutes with direct effect on the total carbon footprint. So we are starting to see the decrease of the emissions with the reference year 2019, because of course 2020 you have a decrease, but it's artificial in a way. So some research labs have, most of them were also the first ones to do the accountancy to measure their footprint, are also engaged in a reduction scheme and have reduced by implementing, for instance, some quotas. But what we are aware of is that we will hit probably some structural limits, also related to how the French system works, which is very centralized. So research institutes or research labs all depend on either a university or a large research institution such as the CNRS or other national research institutions. So without them, large universities or large research institutions such as the CNRS really deciding to enforce some important changes, it will be difficult to reach really ambitious objectives. If we want to reduce by half our footprint, we will need to convince CNRS and the universities and I mean, really at the state level, that a huge effort has to be made to reduce the footprint. And this is what we are trying to do now, because we have much more leverage thanks to all this data, thanks to this large community of people engaged in this effort. We have some leverage when we speak to the president of CNRS or to the Minister of Research and Education. We have much more leverage to try and engage a change, and this is what we are trying to do now. And that's what at least Labo 1.5 is doing now. And that's really the next step. But really, to be precise, some research lab, to answer your question, some research lab have already started to reduce and have managed to reduce mainly using quotas. This is the tool that works the best. So basically, you tell people that they can not spend more than a given amount of tons of CO2 per year, and they have to respect that. And each time they are traveling, they need to measure roughly with some of the tools we've developed, in fact, to measure their carbon footprint. And after reaching a certain quota, they are not allowed to travel anymore. In fact, to be honest, it's not a truly restrictive thing. It's more on the basis of volunteering. So we do not, of course, have research labs do not by themselves have the ability to stop people from traveling. It's not something that we can legally do in a way.
That makes sense. It seems like, talking with astronomers, and I think this is probably true of scientists in general, is that in general, we would like to travel less, but many astronomers feel like they have to either continue their research projects, they need to go to telescopes to get time, or they need to go to conferences to present their research because this is how what they need to do to be successful in their profession. So are there any attempts at laboratories or institutes to take into account the if someone wants to travel less, will there be ways to take that into account as far as like tenure and promotion and other factors to deciding performance? Because obviously if someone is taking the efforts to travel less, we want to make sure that they're not being punished per se in their performance measurements.
Yeah, this is one of the most difficult questions and also most interesting. It's related to how research is evaluated, and it's tough because basically, we have this work which I presented in the talk, where we show that basically those who travel the most are also those with the highest H-index and number of publications. And in the current system, this is something that is perceived as success, having a lot of publication, having a large H-index. So of course, this creates an incentive for people to travel, especially for young people to travel. And for those who are more senior in their careers, it's more a matter of notoriety, and so they also keep flying because they get invited because of this notoriety related to a lot of publication, a lot of visibility, and so they keep on traveling. We've seen in the surveys that we conducted that indeed a large fraction of the traveling is for conferences, and so I think there clearly is a margin there to improve the way we consider conferences and the value we give to visibility in science, and institutions must value other things than just scientific visibility, number of publication, H-index. As you say, I think it's important, like in for the tenure positions, or for getting a permanent position, or for a number of promotions, to consider in a way also what people are doing from the social or environmental point of view. I think this is part of what we call the environmental research ethics at Labo 1.5, and that this is something that must be part of how research is evaluated, not only just research performance as measured by bibliometric indicators, or as measured by scientific productivity.
I wonder if there could be some sort of acknowledgement maybe of if you're able to achieve the same science results with a smaller carbon footprint, that would be commended. It seems to, my opinion is it's not yet clear whether or not that correlation between H-index and travel is an induced correlation or actually reflects the necessity of travel. If you're, one could imagine if you're publishing high impact research, then you're going to be invited to a lot of talks.
Exactly.
But that doesn't necessarily mean that you have a high H-index because you were traveling. Now, of course, the opposite may be true. Because you're traveling, you're getting your name out, people are hearing your talks. But it also seems like, especially now in the world of virtual conferencing and webinars like you and I are doing right now, that there's a much greater opportunity for people to disseminate their research without spending all their time on airplanes traveling from one conference and invited talk to the next.
Yes, this has a lot of benefits, and in fact, there is this recent paper in Nature Sustainability where they show that in addition to the benefits in terms of carbon footprint, there are a number of benefits in terms of inclusiveness. For instance, for people who have family duties, who have, for them, it's difficult to travel. For people with disabilities also, it's much more inclusive to have these hybrid or online conferences. For people who are just, afraid of flying, and in fact, there are a large number of people who are in this case. So in reality, and of course, funding, people who don't have funding cannot afford going to these expensive conferences on an island in an expensive hotel. So it turns out that there are lots of benefits for conferences to be either fully online or in a hybrid format, especially for people who are the most vulnerable. So I think there is a great opportunity. I'm not saying that we have to cut travel completely, because I think it's still important that researchers can meet, scientists can meet and discuss in face-to-face. I think just we have to give much more value to this, and spend, when we are doing this, spend a lot of time, and really that it's just for very specific events that are very important for a given community. Not these conferences where you go to and you just basically give your talk and then spend the rest of your time on your laptop in the conference room, not listening to the talks. How many times have we seen this, at conferences? Or you have these parallel sessions where, there is a million of parallel sessions. So, these things, I think they make no sense. We have to revisit this completely and really go to the core of what is important to reach our goal, which is, producing knowledge, not producing CO2, basically.
I like that. It's interesting. I think people tend to, when thinking about like virtual conferencing, they tend to think about, the inadequacies of the format. And to be clear, there definitely are inadequacies. It's hardly perfect. But they often forget about the inadequacies or difficulties faced with in-person meetings. If you hear people say things like, "Oh, I don't want to do virtual conferencing because I'm afraid my internet is going to disconnect." But at the same time, how many of us have missed conferences or missed our talk at a conference because a flight was canceled or delayed or something like that? And so we're accustomed to the inconveniences and discomforts of in-person travel and conferences, but the issues faced with virtual, I think, are much less and more easily overcome. You've probably seen this. There was an interesting study of research scientists at ETH Zurich, where they were asked about what are their concerns about reducing their travel. And I want to say, I think it's important to focus on travel because that's the quickest and easiest thing we can fix. We talked, you gave a very nice outline and a breakdown of all the different sources. Well, we're going to need to, heat our buildings, and we're going to need to use electricity to run our labs and our telescopes. So there's certain things we have no choice but to do, but travel is perhaps the most easily changed. And so the ETH Zurich study asked what were the biggest concerns with reducing travel. And the majority of people, very few of them said that they were worried they wouldn't actually be able to do their jobs. They were mostly concerned about, one is disseminating the research, and the other is having opportunities to meet collaborators and advance their careers. So I assume these are the similar trends that you're seeing in your surveys. What are you finding the biggest concerns?
Yes. So in the national survey that was conducted, we do have a specific question about this. And I do not remember the details of the phrasing, but basically it's consistent with what was seen at ETH, except of course we extended the sample to a much larger community, which is the national community of research in France, with a random sampling of the email addresses. So we have something that is in principle limited in terms of the biases, and we have in principle, yes, enough statistics to be convinced that what we are seeing is robust, and clearly it's career related issues that people are worried about, and they are also worried about the younger people being not able to develop their career. I think this is clearly the main issue for them. And also, I think, traveling has also always been one of the assets of doing a career in research. And I think now, I mean, it's going to be difficult, especially in countries like France, where the salaries are quite low. We do have a large number of permanent positions, which is the advantage in France, but it's a very competitive field, a lot of pressure, and so traveling has always been sort of something that has attracted people to this type of job. And I must admit that myself, one of the greatest memories in my career were my stays in Japan, for instance, and elsewhere in the world. So it's really we really have to change our state of mind, and I think that's quite difficult. And I think also people are maybe not fully honest, when they say what they're afraid of. I think many of them also fear, just the enjoyment of traveling. There is a part of just discovering new cultures in this, which is something that is quite enjoyable. And there is this paper by Higam and Font in New Zealand, where they looked at this, but from a qualitative ethnographic point of view, and they show that the motives of traveling are really various and depend on status, on career advancement. It's quite interesting to read, and I think this paper is also quite nice because it shows a relatively wide panorama of the incentives and reason why people are traveling in academia.
I've only had one astronomer openly admit to me that he doesn't want to give up travel because he loves the free vacations. But I think we all feel that way, right? I mean, it's an opportunity, as you say, it's an opportunity to visit new places. I think there's also quite a bit of prestige associated with it as well.
Yes.
That you can say that, you were invited to give a talk in another country, halfway across
Absolutely.
the world. And it doesn't have the same, it doesn't have the same feel to say, oh, well, I was invited to wake up at 3 a.m. and give a talk online, right, from my kitchen. So that's certainly part of it. And to be sure, there's no substitute for the kinds of interaction that you can have in person. One of my long-term collaborators is someone that I just happened to sit next to at a conference dinner, and not only did we have scientific interests, but we became good friends. And so that dynamic is harder to produce online, but not impossible. And that's something that I think is very important to emphasize, is that in the last 2 years, with the proliferation of virtual conferencing, I think all of us are experiencing a greater ability to connect with others, because it's just simply easier to do so, that you can participate in things online much more easily and therefore frequently than you can in person. So I certainly miss those, conference trips to other parts of the world, but I also find that scientifically I've been able to be very productive without them. Do you have any statistics or reflections on, obviously COVID is still ongoing, and it's only been 2 years since we've had to change our travel habits as a result, but do you have any insights on how the science as a profession is changed in France, or astronomy has changed such that we've been able to accommodate this necessity?
I think, well, there are different things, but clearly there has been a change in terms of state of mind I think when we started this project, the Labo 1.5 project, we were kind of the crazy activists in a way, 3 years after, I think, people, well, a lot of people know us in the French scientific community, at least I think so. Clearly, I think now many people see this question as something that is central to our research activity, and that it's something you cannot dismiss. And also, I think in a way, COVID has helped because it also showed that when there is a necessity, you can adapt. When we started, I don't know if people really remember this, but that was only 3 years ago. But in 2019, doing Zoom and having these online events, etc., was something people did not imagine was possible. I remember we did the first meetings, the online meetings with as part of Labo 1.5. So they were national meetings using WebEx. I think we used WebEx. And, it was super complicated because people did not know how to mute their mics because we had some issues with connections, So we had all kinds of issues. And, at the end, people were all saying, okay, guys, this online thing is never going to work for real. And then, at one point, we had no choice. And everyone adapted super quickly in less than a year. And also the tools, of course, that were developed very quickly for that. And so there was a big change in terms of state of mind and a very quick adaptation. So I would say, in terms of the structural changes, I think they have not come yet. That's what I was saying earlier. The reduction is also not there yet, but I think the state of minds really have changed. And we don't feel ridiculous at all. We have this very large number of research labs involved in this in the measurement of their carbon footprint. When we talk to CNRS or other national institutions, they treat us with a lot of respect. They listen to what we have to say. They follow some recommendations that we give. So I think this really has been a great political victory. And also, it's something I have not mentioned, but we created what we call this administrative tool. It's called Groupement de Recherche in France. It's like an administrative structure which allows people in any research institution in France to declare part of their time on activities related to what we are doing as part of this Labo 1.5 project. So it means that anyone can say, I'm spending 5% of my time, 10% of my time on this Labo 1.5 project. And so it's their work time. So it's not something they're doing on the weekends. It's really part of their work to contribute to this change of transformation of how we are doing research. And that was also for us a political victory, I would say. It was really difficult to have large institutions and universities understand that this has to be part of the job, basically. And we managed to have them accept that. I think now there are 250 participants who declare time officially in the project. So it's like a big project. It's like a very large research project, but dedicated to the environmental footprint of research in France. So that's a success for us also.
Oh, that's a fantastic success story, and that basically leads into my last question for you for today, which is, what advice do you have for A4E members who are interested in getting institutional change, going to, whether it be in their institution or their department or their university? What are tips you have for ways that they can bring about this change in their workplace?
My advice, and this is something I discussed also with the members of the European community for A4E. Actually, I gave a small presentation about this very topic.
Oh, perfect.
And yeah, and this is something we discussed with Leo Butcher several times. My recommendation is think about the ways to get leverage, because you get changes only with leverage. I think, pledge or imploring, I don't know if you say that in English, but asking for permission, asking the people who have power to make the changes, this doesn't work. I think you need to get power, and then you can talk to those who have power and tell them, I also have power. You have to make these changes, and that's how you can have some leverage. This is what we've been trying to do with Labo 1.5. For instance, from the beginning, when we started this project, we said, we are not going to ask permission. We are just going to do it. We are going to measure the carbon footprint of research in France. We are going to develop this tool. We are going to make it for free. We are going to give it to all the people in the community. They're going to be able to use it. And, at one point, the national institutions in France came to us and said, guys, what are you doing? We are very interested. We don't know how to make a carbon footprint measurement. What's your plan? And we had to, create this leverage from the number of people who were involved, the tool, the fact that it's open source, the fact that we have built a big database in which they're interested as well, these big institutions. All this is a strategy that we thought from the beginning to get some leverage in order to have changes to happen, because as I said, I'm a bit pessimistic on this, but asking people who have power to make changes, I think doesn't work. At least that's my experience as as an activist, I would say.
Okay. And that actually will lead me to the last question I have for you, and that is, many scientists, you just identified yourself as an activist. That's a term that many scientists feel uncomfortable with, that they feel like that as scientists, we should remain impartial. It's often described as the ivory tower, this place that scientists occupy. What is your advice for scientists who are interested in being more actively engaged in advocacy, who may feel reluctant to work in that space?
I think it's very important to understand the difference between neutrality related to facts and neutrality related to values. I think these are two different things which need to be separated in research. I believe that scientific research aims at finding the truth, and that's what I call neutrality of facts. You need to identify the facts as they are and publish them as they are, just the facts as much as possible. And on this, you need to be neutral. But when it gets to values, it's a different story. And it's about the ethics of research, of how you're doing research. And that's something researchers must think about. They must think about how research should be done in terms of practices and in terms of objectives. Do we agree to do research on human embryos or not? That's a question we need to ask ourselves. That's not being an activist. That's just a question of values. Do we agree that research on fracking is okay, or nuclear weapons is okay? Do we agree that flying as much as we can is okay? All these questions, I do not have the answer. It's not my point, but I think it's questions of values that we need to discuss in the scientific community with the rest of the society. This is very important. And that's not being an activist. That's just thinking how the production of knowledge happens in the society. And that's what we are trying to do. And this can be completely separated from the scientific work. It's like when a doctor, you go to the doctor and he inspects you, or you go to have surgery. You don't ask if this person is an activist, if he is left wing or right wing. It doesn't matter. This person is going to do his or her work properly. You just trust the work. I think for a scientist, it's the same. You just do your work with a neutrality related to the facts, and try to do science properly, and then you can be dedicated to thinking about the system of production of knowledge, how this works, what are the ethics that apply to it, and limit academic freedom. I think all these questions are very important, and I think all scientists should think about this. And I don't think this is political activism in the negative way. It's just I think thinking ourselves in the noble political sense.
I think I like the way that you explain that. I think that's great. Well, thank you so much, Olivier, for joining us.
Thanks.
And for those of you watching this recording, we will put a link to Olivier's talk that you mentioned earlier, as well as some of the other resources that were mentioned here. So thank you again, and it's been wonderful talking with you, and I look forward to seeing you again soon.
Thanks.
If you're interested in Astronomers for Planet Earth, you can learn more at our website, astronomersforplanet.earth, and on social media as well. If you would like to be notified about future talks and events, please follow and join us.